This is more solving for exponential equations. So before, when we had our exponential equations, we would change their bases so that we can set the exponents equal. But with these, it's not possible. You can't turn an 11 into a base of 5 without doing a lot of work. So we use another technique, and we go back to what we learned in sum and difference of logarithms. If you have a log in front of this situation, you can take that exponent and put it right in front. So when we have these, we put a log on each side. So we take the log of the left and the log of the right, and that allows us to take this exponent and put it in front. Now we do not have an exponential equation anymore. We have an equation that we can solve. So we divide by 3 log of 5, plug it all in your calculator, and it gives us an answer. That's it. So if you see that you cannot make the bases the same, then you put a log on each side. Now you want to choose your logarithm wisely. So I don't want to use log here. I want to use ln, because ln is the base for e, has a base of e. So this is really log base e, which means it will allow me to bring this down, just like any normal logarithm. However, I'm now left with ln of e. And what is the natural log of e? So if you remember, natural log of e is 1, because they cancel each other, right? So you can just basically throw it away because it's 1, and there's our equation. So now we can just divide by 0.06 and plug that into our calculator. So we'll take ln of 30 and divide it by 0.006. So I have to re-enter it. ln of 30 divided by 0.006. And there it is. 566.87. I'm going to round it. 566.87. Alright, and so now all that's left is to check it. So we're going to take this number, plug it back into our exponential. It's already entered. And I use the whole thing to give me a better answer. Hit equals. And that's basically 30. And that's it. So you choose a logarithm for each side. If you pick the one with the same base, it'll cancel it. Alright. What if it's in this form? So it's not already set up as one exponential. So what you have to do is solve. And I like to circle it. And you treat this one just like it's the x. So that means you have to add 2 to both sides. So we get 8 times 6x equals 8. And then divide by 8. So that's 6x, 6 to the power of x equals 1. Now we can put a log on both sides. And you could use a log base 6, but I don't want to enter that into my calculator, so I'm going to leave it as a plain log base 10. And then log of 1 is 0. And then we can take our x and bring it in front. And now we have our nice linear equation. So, if we divide by log of 6, and we don't have to enter that in the calculator because it's 0, x is 0. And how do we know it's correct? We plug it back in. 6 to the 0 is 1. And 8 minus 2 is 6. Checks out. Alright? Let me do one more and then I'll let you try some. So what if you have an exponent on both sides? So then we go log of both sides. And that allows us to bring the exponent in front. But make sure you put a parenthesis around it, because there are 2 terms there. And there's our equation. Now what I like to do is take this and divide it off to the other side. This allows me to not have to distribute anything. And it gives me one number here. So we have x log of 4 over log of 3. And you have an option. You can use the logarithm and solve it completely and get an exact answer, or we can just go for the approximate, which is what I'm going to do. So we're going to take log of 4 and divide it by log of 3. So log of 4 divided by log of 3. You could also make it into a change of base. There's a lot of options, but we're going to use a bunch of decimals, so 1.26186, that's what we're going to use. 1.26186. 1.26186x. Let me double check it. 1.26186. There we go. So you could also have made x and then log of 4 base 3, but it's going to get complicated if we don't. So now we have a nice linear equation. We can just solve it by subtracting x and subtracting 1x. That's all we have is 1x there. And this gives us 0.26186x, and then we can just divide. And the nice thing with calculators is it remembers the value, so we can enter it in this way and get a very good answer, which is 3.19. We'll say 3.19. So x equals 3.19. 189. 819. There we go. Okay. 819. But if you don't, you can just enter it in the way we have it. So it's 1 divided by 0.26186. 0.26186. And it's still the same thing, 3.819. So, as long as you have enough decimals, it'll work out and give you a good approximation. Let's circle it, and then we're going to check it. So we bring up the calculator, and we go 3 exponent parenthesis 1 plus what we just got. Hit enter. And then we do the same thing. So it's about 199. So now it's 4 to the exponent of what we just got. 199.144. See? Same answer, so we're good. This is the correct answer. Alright, there are 2 problems for you to try. So remember, you need to isolate your exponent first and then try the logarithm, and then this one's ready to go. So hit pause and give them a shot. And there are the answers. So we had to isolate the exponential first, and then we could put a log on each side, bringing down the 3x. And since it's just the 1x, we just go straight ahead and divide. Plug it in your calculator, you get this. Make sure you put a parenthesis on the denominator. If it's not giving you that answer, it's probably because you did not parenthesis the entire denominator. And then over here, it's already isolated, so we can log both sides. Bring down the 2x plus 1, but I didn't want to distribute the log of 7, so I divided it over here. Plug that in my calculator, and it gave me a decimal. Solve my equation, and there's my answer. And that's it.